This video will explore electrostatics and Coulomb's law, covering fundamental charges to electric fields. We'll use the formula F equals K times absolute value of Q1 times Q2 divided by R squared to quantify the forces between charges. Electric charge involves two types, positive protons and negative electrons. Like charges repel and opposites attract. The SI unit for charge is the Coulomb. The magnitude of charge for a single electron or proton, denoted by E, is 1.60 times 10 to the minus 19 coulombs. Materials can be conductors, allowing free charge flow, or insulators, which do not. Coulomb's law quantifies the interaction between point charges. The electrostatic force F equals the Coulomb constant K times the product of the magnitudes of the charges Q1 and Q2 divided by the distance R squared. This force, F, is measured in newtons. Now, let's try a practice problem. 2-point charges, plus 2.0 micro-Coulombs and plus 3.0 micro-Coulombs, are separated by 0.30 meters. We need to calculate the magnitude of the electrostatic force between them using the Coulomb constant, K. First, identify the givens and convert units to coulombs and meters. Next, substitute these values into Coulomb's law. After calculation, we find that the magnitude of the electrostatic force is approximately 0.60 newtons. Since both charges are positive, the force is repulsive.